Today we'll be talking about the double and half angle identity. Now what does double mean? Multiply by 2. So if you notice in the formulas for the double angles, all of the angle A's are being multiplied by 2. So for the sine of 2A, we have 2 times the sine of A times the cosine of A. For the cosine of 2A, we have 3 different formulas we can use, and you can pick which formula you use depending on what information you have in your problem. So if you're given the cosine and sine, then you can use the first formula. If you're only given the sine value, you'd have to use the second formula, and if you're only given the cosine value, you'll have to use that third formula. So there's 3 separate formulas for cosine of 2A. For tangent of 2A, it's 2 times the tangent of A, and in the denominator we have the difference of 1 and tangent squared of A. Now in that second column we have the half angle identity. And if you notice, all of the angle A's are being what? They're being halved. They're being divided by 2. And notice all of these formulas have a square root. They also have a plus or minus, because remember, when you take a square root, you can have a positive solution as well as a negative solution. But when we're writing our answers today, you're not going to have the plus or minus. You're only going to have one of them, and you'll have to choose which one you have to use. So you're going to choose whether it's going to be positive or negative based on the terminal side of the angle. So if you think about our coordinate plane, we know in quadrant 1, sine and cosine are both positive. In quadrant 3, sine and cosine are both negative. Quadrant 2, sine is positive, cosine is negative. Quadrant 4, sine is negative, cosine is positive. So based on the information, whether you're given the sine, cosine, or tangent, you'll need to then look at your angle and determine in which quadrant would that angle terminate, and then decide if your answer should be positive or negative. Now, let's go ahead and look at some examples. But before we do that, I do need to mention that on the test next week, you don't have to memorize these formulas. They will be on the formula handout. So you don't have to memorize these, but you do have to know how to use them. So let's look at number 1. Number 1, the instructions say simplify the given expression. So since we don't have a square root, I know I don't need to be looking in the half angle identities. So this is going to be one of the double angle identities. And does this look like the double angle identity for sine, cosine, or tangent? Sine, because the formula is 2 sine A cosine A is equal to cosine, not cosine. What is this equal to? The sine of 2A. So when I write my answer, I need to have sine, and then we need to have 2, and 2 needs to be multiplied by the A value, and what angle are they using for A? 45 degrees. So this is going to be the sine of 2 times 45 degrees. And 2 times 45 degrees would be 90 degrees. Can I simplify that? Yes, I can. Think about our unit circle. 90 degrees would be at the top. What is that point as an ordered pair? 0, 1. So what's the sine of 90 degrees? 1. So the answer to number 1 is 1. Next one, number 2. We have 1 minus 2 sine squared of 25 degrees. Now again, it's not under a square root, so it's not a half angle identity. It's going to be a double angle identity. And is this a double angle identity for sine, cosine, or tangent? Cosine. So this is 1 minus 2 sine squared of A is equal to cosine of 2A. That's the formula they're using here. So when I write my answer needs to be cosine of 2 times, what value are they using for A? 25 degrees. Simplify that, 2 times 25 degrees, 50 degrees. Now, is 50 degrees a value we memorized on the unit circle? No, so we'll just leave it as cosine of 50 degrees. Moving on, number 3. Now we have 2 tangent of 104 degrees over 1 minus tangent squared of 104 degrees. Again, this is not under a square root, so it's not a half angle identity. It must be a double angle identity. And this is the double angle identity for sine, cosine, or tangent. Tangent, so this would be the tangent of 2A, but they're not using A. What are they using? 104 degrees. And what's 2 times 104? So this would be tangent of 208 degrees. Is 208 degrees a value we memorized on the unit circle? No. So that is our simplified answer, tangent of 208 degrees. And number 4. Again, this needs to be a double angle identity, but for those double angle identities, does it have a 6 in it in any of those formulas? What about a 3? No, but that formula looks closest to which one? Yeah, it looks like the formula of 2 cosine squared A minus 1. But, let's see, so it's kind of similar to this, 2 cosine squared of A minus 1, but they don't have a 2 out front. What do they have? A 6. So what should I put out front here? 3. So notice if I distribute 3 times 2 cosine squared A would be 6 cosine squared, and 3 times negative 1 would be negative 3 is correct. Now, instead of A, what should I have used? X. And let me amend this, and let me go ahead and just change this to an X. So the 2 cosine squared X is equivalent to, is that sine of 2A, cosine 2A, or tangent of 2A? Cosine of 2 times, instead of A, they're using X. Don't leave that multiplication symbol in your answer. So this is just 3 times the cosine of 2x. So 3 times the cosine of 2x. So it didn't have the 2 out front, so we factored out the 3 to get us the 2 as the formula has it. Next problem. Number 5, this one's similar because we don't have a 2. What do we have? An 8. So normally, this one looks like sine of 2a, cosine 2a, or tangent of 2a. Yeah, it looks like sine of 2a, and for sine of 2a, this should have been 2 cosine x sine x, but what did they multiply the 2 by to get an 8? 4. So they multiplied the 2 cosine x sine x by 4 to get the 8. Doesn't matter which way you put the sign. Oh, this, well, technically it doesn't matter, but if I use the same as what your formula is, your formula has it written as sine x cosine x. Technically it's right either way, but I'm going to make it look like your formula. So bring down the 4, and 2 sine x cosine x, is that the formula for sine of 2a, cosine of 2a, or tangent of 2a? Sine of 2a. So this is 4 times the sine of 2a, but a, they're using x. And I'm just going to erase that multiplication and just put x. So 4 times the sine of 2x. Next one, number 6. We have sine of 3 theta, cosine of 3 theta. Now, which one is that closest to looking like? Sine of 2a. And for sine of 2a, they should have used 2 sine of 3 theta, cosine of 3 theta. That's what it should look like. But they don't have a 2 out front. What do they have? A 1. So what was the 2 multiplied by to get the 1? 1/2. So this is 1/2 times 2 will get us 1 sine x cosine x. So what you need to do is just write out what the formula should look like and figure out what was multiplied to get the original value. So we should have had a 2 out front. So in order to get a 1, you'd have to cut it in half or multiply by 1/2. Now, when we solve this, the 2 sine A cosine A is for sine of 2A. But what are they using for A here? Not theta, 3 theta. This is 2 sine A cosine A. So for A, they're using 3 theta. So go ahead and multiply that. So this is going to be 1/2 times the sine of 2 times 3 theta would be 6 theta. No, just the coefficients are multiplied. This is part of the angle, so the angle is not cut in half. Next one, now we have one with tangent. So this should look like for the tangent of 2a, but the formula for tangent of 2a doesn't start with a 4. What does it start with? So write out what it should have been. It should have been 2 tangent of 150 degrees over 1 minus tangent squared of 150 degrees. So write out what it should have been and figure out what they multiplied by to get a 4. They multiplied by 2. So this is equal to 2 times the tangent of 2a, but instead of a, what are they using? 150 degrees. Simplify that. 2 times 150 degrees is 300 degrees. And I can keep going. I can figure out what is the tangent of 300 degrees. Well, tangent is sine over cosine. What's the reference angle for 300 degrees? 60 degrees. So the sine of 60 degrees, square root of 3 over 2, and the sine or cosine is 1 over 2. And if we're talking about 300 degrees, which quadrant does it fall in? Quadrant 4 is where it terminates. And I know in quadrant 4, the sine is negative, the cosine is positive. So that means my tangent will be negative. And those 2's cancel. And so what's the tangent of 300 degrees? Negative square root of 3. Multiply those. 2 times negative square root of 3 is negative 2 square root of 3. Number 8. Now I have a square root. So if you have a square root, it's going to be one of the half angle identities. So notice we have a 1 plus cosine, and we have a 2 in the denominator. So which one of those has 1 plus cosine in the numerator and a 2 in the denominator? Cosine of a over 2. So this is equal to cosine of a. What are they using? 60 degrees over 2. And 60 degrees over 2 would be 30 degrees. And that's one of the trig values we should have memorized. Cosine of 30 degrees is square root of 3 over 2. Next one. We have a 1 minus cosine and a 2 in the denominator. So which one is this paired with? Sine of a over 2. So this would be sine of a. What are they using for a? Pi over 8. And it needs to be divided by 2. We need to simplify that. So if I make this 2 over 1, yeah, I'd multiply by the reciprocal. The reciprocal would be 1 over 2. And pi over 8 times 1/2 is pi over 16. And is pi over 16 one of the trig values we memorized on the unit circle? No. So we stop here. Sine of pi over 16. And the last one for this example, we have problem number 10. For number 10, notice we have the plus or minus here. So we'll have to decide, will our answer be positive or negative? So let's start. Now notice this one has a 1 minus cosine in the numerator and a 1 plus cosine in the denominator. So would this be sine of a over 2, cosine of a over 2, or tangent of a over 2? Tangent. So this is tangent of a over 2. Instead of a, they're using 120 degrees over 2. And what's 120 degrees divided by 2? This would be the tangent of 60 degrees, and 60 degrees terminates in which quadrant? 1, so would my answer be positive or negative? Positive. And what's the tangent of 60 degrees? Let's say the sine over cosine. The sine of 60 is square root of 3 over 2, and the cosine of 60 is 1 over 2. So the tangent of 60 degrees is square root of 3. You should have a little bit of deja vu. I've done this before, haven't I? Over here with 300 degrees? Okay, moving on to the next section. It says use a half angle identity to find each exact value. So for number 11, the angle we're given is 165 degrees. Well, it's already been cut in half. So we have to figure out what angle was cut in half to give us 165 degrees. We'll just multiply 165 by 2. What do you get? 330. So this would be the sine of 330 degrees over 2. Now using the formula, and this is a half angle formula, it's going to equal plus or minus. You only put the plus or minus in the original formula, only in the first step. So it's plus or minus 1 minus cosine A. Instead of A, let's go ahead and put what A is. And what's the value for A here? 330 degrees. Over 2. Now, again, you're only going to put the plus or minus in the first step. So from here on out, I have to figure out, is my answer positive or is my answer negative? Well, to figure that out, always look at your problem. So look at the original problem to figure out if it's positive or negative. Well, 165 terminates in which quadrant? Quadrant 2. So if I'm talking about sine in quadrant 2, should my answer be positive or negative? Positive. So I'm just going to circle the positive as a reminder to myself that I ask myself, is it positive or negative? And it needs to be a positive. So from here forward, I know it's positive. So if it's positive, you don't have to put a plus sign. It's understood. Now fill in what we know. So it's 1 minus cosine of 330 degrees. What's the reference angle for 330